In this video, we'll cover the first two sections of Chapter 3 on designing studies. We'll look at the different types of study design. We'll consider some issues in the design of sample survey questions, and look at some issues that apply to all study designs. What we're covering today falls under the first of the four processes of statistics. It's important to note that not only does this process involve selecting a sample, but also appropriately designing a study. Today we're going to talk about ways that we can avoid some common mistakes that people make when designing studies. Let's start by looking at a few definitions. An observational study is a study in which researchers look at the values of variables as they actually are. It's important to note that the researchers do not have any control over the values of the variables, but rather simply observe what the values are. Observational studies may be retrospective, in which the researchers look at things that have happened in the past, or they can be prospective, where researchers follow along and see what happens in the future. One specific type of observational study is a sample survey. In a sample survey, the members of the population, or the sample, I should say, report their own values for the variables. This leads to several problems that we'll talk about later on in this video. An experiment is a study in which researchers have control over the variables. Finally, anecdotal evidence is something that can come up in a sample survey. Anecdotal evidence are personal accounts by one or a few individuals selected haphazardly or by convenience. Always be sure to avoid anecdotal evidence. For now, though, let's focus on the sample survey. Remember that sample surveys are a special case of observational studies. When we're producing data from an observational study, there are two steps. We first need to obtain an unbiased sample. Second, we need to assess the values of the variables in a way that is unbiased. That's potentially a problem because sample surveys are often self-reported, and questions can be designed in such a way that introduces bias, sometimes knowingly and sometimes unknowingly. Let's talk about some of those issues involved in designing a sample survey. One thing that the researcher must consider is whether to include open or closed questions. Another thing to be on the lookout for are unbalanced response options, leading questions, complicated questions, sensitive questions, and questions involving hard to define concepts. We're going to look at all of these as we go through the rest of this lecture. Let's start with open versus closed questions. So imagine seeing this on an exam. What kind of question is this? A, open, B, closed. And the second question, what is an open question? Well, in order to answer these, we need a definition. So first, an open question is a question that allows any possible response. You can think of that open as in open-ended. A closed question only permits a finite number of responses. Multiple choice questions, true-false questions, questions that ask you to choose from among a list of options, those are all closed questions. So, number one is a closed question because we only have two options. Number two, an open question is one that allows for unlimited possible responses. So here are our definitions. An open question does not have a fixed set of response options, whereas a closed question does. It's important to know that a closed question might simply imply a set of possible responses without ever giving them explicitly. Now let's look at an example of a question with overly restrictive options. A neuroscientist asked survey respondents, "How often do you dream in color?" Answer: always, sometimes, or never. Notice this is a closed question. There are only 3 options. Think about it for a second. How would you respond to this? What if you're like me and you don't often remember your dreams? How can we improve this question? Well, the problem with this question is the options, always, sometimes, or never, imply that you always remember your dreams and you always remember whether they were in color or not. That's a little too restrictive. Maybe some options like "I can't remember," or "I don't know," or "I'm not sure" would help some respondents answer this truthfully. In a situation where a respondent doesn't remember at all, they must choose one of the 3 options, always, sometimes, or never, that could lead to bias in the responses. Now let's look at unbalanced response options. Let's say that 91% of Americans surveyed rated their own health as good to excellent. Would that result be surprising to you? Do you think that number is high or low? Personally, I'm pretty surprised by that 91%, and I think it's high. Why do you think that is? What if the survey question from which this set of data was taken was a closed question that offered these 5 options? Now, does that make you less surprised about the response? I would buy it now. And the reason is that the middle option is good here. Since good is the middle option, people who feel that their health is just sort of okay are going to take that choice right in the middle. Next, we'll look at examples of deliberate bias. Let's look at a question that was posted on this website. If my child or spouse were assaulted, I would choose one of these. Run away and hope my kid or spouse can keep up. That seems pretty callous. Be a good witness so I can tell the cops what happened later. Try to convince the attacker to stop through verbal persuasion. Or option number 4, fight to stop the attack. I don't know about you guys, but one of these options seems like the only possible good answer, and it's that last one. Here, the surveyor has given us 3 unattractive options and 1 good option. Of course, people are going to choose option 4, whether it's the truth or not. This is an example of a deliberate bias. Anytime that it's apparent just from the way the question is worded what response the surveyor wants, then statistically speaking, we cannot use those results. Now let's look at an example of an overly complicated question. A surveyor asked for a homemaker to agree or disagree with the statement, "I don't go out of my way to purchase low-fat foods unless they're also low in calories." How can this survey question be improved? Well, I'm not even sure what that survey question means. With "I don't go out of my way to purchase low-fat foods unless they're also low in calories," I'm not sure if I agree with this or not, partly because it's hard to understand. it's almost like there's a double negative in there, and that word unless can mean different things to different people. So I don't know. What do we think? I think this question could be improved maybe if we divide it up into two pieces. Ask about low-fat foods and ask about low-calorie foods. Now let's look at a question that is controversial. An anonymous Pennsylvania youth survey given to 6th through 12th grade public school students asked, how old were you when you first did the following? Got suspended from school, got arrested, carried a handgun, and so forth. The options that were given were I never have, 10 or younger, 11, 12, 13, up to 17. Parents objected to this question. Can you think of a reason why? On the other hand, can you think of a reason why the question might be worded this way? Well, in this case, parents were upset because the way the question is worded, it seems like it would be natural if you had been suspended from school or got arrested or carried a handgun. It almost feels like it expects that everyone would answer that they have done all these things. On the other hand, if you're really looking for honest responses, you don't want the respondents to feel shamed or get a sense of sort of a negative connotation for them to be honest about. We don't want them to feel bad about themselves. If they do feel bad about themselves, they might lie about it. So by wording the question this way, it seems like it's making it sound like these are acceptable. But the question's being asked this way so that the respondents don't feel judged if they do say that they have been arrested or so forth. This is a tricky situation. Let's look at another phenomenon that people have noticed about surveys. A computer program was piloted in a stats class where students agreed to be identified by name. But even though the students were identified by name, one student filled in the boxes with obscenities. Why would the student do this in the computer lab and not in homework or exams in which things are handwritten and handed in? Something that researchers have noticed is that hiding behind a keyboard gives people a sense of anonymity. People are more likely to say something on a computer than they would be in a way that's more personal, like handwritten notes. I'm sure you've all seen examples of this in the past. Now, let's take a look at some broader issues. Any study has a couple of things that we need to consider. The first is the size of the sample under consideration. And the second is how to handle errors in the conclusions in the study. Let's start with the sample size. Let's talk a little bit about sample size. Researchers want to know if stronger sunscreens cause people to spend more time in the sun. They could test this with an observational study or an experiment. Before we get into the details of how the sample size affects things, let's talk a little bit about what the observational study would look like and what the experiment would look like. If this were being done as an experiment, the researchers would give people different strengths of sunscreen and ask them to use them every day. Here, the researchers are controlling that variable of what strength of sunscreen people are using. In an observational study, researchers would ask people if they use sunscreen, if so, how strong it is, and then how much time they spend in the sun. That's an important distinction and one that I hope you all get used to. Now, let's think about this as an observational study. Which is better in this case, if we use 10 students for the observational study or 100 students? Well, it depends. If the study is flawed in some way, If it's an observational study or an experiment that's designed badly, then it doesn't matter how big the sample is because the results are not going to be terribly useful. If the study is well designed, however, the larger sample is always better. Now that we talked about sample size, let's talk about errors and conclusions. Let's look at an example investigating the two types of errors. Let's imagine a study in which radar guns are being tested to see if they work. What types of errors could we make here? Broadly speaking, there are two types of errors in general that we're going to see: false positives and false negatives. In this case, what would a false negative look like? A false negative would say that the guns don't work, when in fact they do work. The consequence of this would be that the guns might be replaced when they don't need to be, or they might be fixed when they don't need to be fixed. At any rate, money would be spent that didn't need to be spent. A false positive would be concluding that the guns work when actually they don't. The consequence here, I think, is worse. That means that the police force would be issuing speeding tickets to people who don't deserve them, or not issuing speeding tickets to people who do deserve them. I think that latter error is much more dangerous. Let's talk about how sample size can affect these types of errors. In the same situation where we're looking at radar guns, which error would be more likely to be made if the researchers only look at a small sample of guns? Well, remember, we're looking at the possibility of a false negative and a false positive. A false negative would be concluding that the guns in general don't work when they really do. A false positive would be concluding that the guns do work when, in fact, they really don't. Which of these is more likely in this situation? Well, as we said before, the more costly error here is the false positive, concluding they work when they really don't. And if we're looking at the entire production run of these guns must have passed some sort of quality control at the factory where they were produced. And now our second round of testing is trying to verify that. If we only look at a small sample, let's say that 100,000 of these guns were made, and we look at 10 of them. Well, if, let's say, 5% of the guns are faulty, is it possible that we, in our choosing our 10, just pick 10 that all worked fine? That's the most likely outcome here, I think. Let's look at another example. A study is looking at limitations and risks in the use of home drug testing kits. When you think about a home drug testing kit, what kind of errors could we make here, and how could they cause a problem? What are the consequences? Well, again, we have false positives and we have false negatives. The false positive, which could be due to foods or other medications, would result in an innocent person being incriminated. Whereas a false negative results in someone who is a drug user maybe not getting the help they need. Let's wrap things up. Remember, we talked about open questions versus closed questions. Remember, closed questions are questions in which you have a finite number of possible responses. Open questions are the opposite. We saw what can happen with unbalanced response options. In the example we saw, remember, there were 5 choices, 3 of which were good or had positive connotations, and 2 of which had negative connotations, without sort of a neutral in the middle. We saw what can happen with leading questions when it is obvious what a researcher wants to hear. We talked about overly complicated questions, a problem that can be fixed by either rewording or breaking up questions into multiple parts. We saw what can happen with sensitive questions or with hard to define concepts. That last one we didn't talk a whole lot about, so let me kind of put together, give you a sense of what that means. An example of a hard to define concept might be happiness. If I asked you on a scale from 1 to 10, how happy are you? With 10 being completely happy and 1 being completely unhappy. Happiness is a concept that's hard to define. One person's 7 might be another person's 4. Since there is no objective way to quantify happiness, that's a concept that's hard to define. We also looked at a couple of issues that can pop up with any study design. Issues with the sample size. Remember, as long as the study or the experiment is designed well, the bigger the sample, the better. And we looked at the 2 types of errors we can see in conclusions. Thanks for watching.